Now for something completely different.
Yeah, let's change it up. Okay, so it says 1 dozen eggs equals 12 eggs. Okay.
Yeah.
75 eggs equals how many dozen? 2.4 dozen eggs equals how many?
When you have an equation, when you have 1 dozen equals 12 eggs, you can make 2 fractions out of this, right?
Yes. Yes, you can. Go ahead and start writing out what are those 2 fractions that you could make.
We've done something like this before already, haven't we?
I can't remember if it was for this class or AP, honestly.
Oh yeah, that's right.
Okay. All right, so it can look like this. 1 dozen over, eggs is 12 eggs.
You're a much harder worker than I am. I always just did DZ for dozen.
Well, that's a good idea. Okay, or it can be 12 eggs over 1 dozen eggs.
Yep,
Okay.
2 fractions.
Okay, so those are 2 fractions. Now, the question is, I really hate this black marker.
75 eggs is how many dozens? So you're going to take 75 eggs and multiply it times one of those fractions. Which one should you choose?
Okay, well, so if we're trying to figure out 75 eggs, I always do the train tracks. And,
I like that.
You know, if you're not a train track person and you just want to do multiplication, division, do it, okay? So always start with what you know, 75 eggs. And what are we trying to find here?
How many dozen that is.
Okay.
So the answer is going to have dozen as the units.
Okay, I'm going to put that over here. Oh, I'm writing out dozen again. And then we've got eggs right here, and we need these 2 things need to cancel out. So down here needs to be eggs too, right?
Yep.
Okay, so which one works?
Well, you want 1 dozen on the top and 12
Yeah.
eggs on the bottom.
Boom, like that. Okay. All right, and my handy dandy calculator. Thank you, sir. Okay, so we've got 75 divided by 12, and you get 6.25 dozen eggs.
6.25 dozen. 6 1/4 dozen.
Okay, so a dozen.
So
Six
see how
1/4
simple
dozen.
that is? And the
Yeah.
question is, what goes on the bottom? The thing that you're given. What goes on the top? The unit that you want.
Mm-hmm. Yep, what you're given goes in the bottom because you got to make those units cancel. All right, and then the next thing is 2.4 dozen eggs equals how many eggs?
So we're starting with dozen, and we want to have eggs in the answer.
Oh, let's erase the whole thing. Okay. All right, so boop, 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 boop. So you said we're starting with dozen, 2.4 dozen to be exact. Okay.
So what do we want on the bottom of the fraction?
Okay, we want dozen on the bottom then.
Yeah.
Right? We want whatever we're given, we want to put on the bottom so it cancels out.
Yeah.
And we're trying to find eggs here.
Yep.
Okay, so on the top, we're gonna use this one then, right?
Yep.
Okay, 1 dozen, 12 eggs. 2.4 times 12 is. Come on, human calculator. I was hoping you got something for me. 28.8. 28.8 eggs.
Somebody broke an egg.
Yeah, can you have a part of an egg? Oh my gosh, last night I was making eggs and I cracked it and I spilled it all over the counter and then I picked it up to try and put some of the egg back in the pan. Anyways, the struggle.
Made a mess.
The struggle. Okay. All right. So, wrong way. There we go. So, does this make sense, ladies and gentlemen? Is this good?
You guys have done this kind of stuff before.
This is doable, right?
We're going to need that because here's a new idea.
Okay. So the unit of charge is the Coulomb.
Symbolized by the capital letter C.
1 Coulomb equals the charge on 6.25 times 10 to the 18th electrons, or 6.25 times 10 to the 18th protons.
That is a lot of electrons. That's a lot of protons.
Yes, it's a very big number.
Yeah, a Coulomb of charge is a huge amount of charge. It's a dangerous, you will not find 1 Coulomb of charge, positive or negative, by itself in nature. It's far too dangerous.
So you're saying if I had this many protons, I would have 1 Coulomb of charge.
That's right.
Okay, and this many electrons, 1 Coulomb of charge. How come they're the same?
Well, because the charge on electron is +1, and the charge electron is -1. The charge on proton is they have the same charge, just opposite sign.
Yeah. Okay. What could be the charge on 1 electron?
So we need to make fractions
Ooh, let me go to
out of what we had before.
Yeah, I was like, let me go ahead and write those things down. So we said 1 Coulomb
1C
equals 6.25
0.25
times 10 to the
18.
18th. Dang. Okay. Protons, you know, or electrons.
Yep.
Okay. Now, what's our question?
What would be the charge on one electron? So you got one electron.
Okay.
You want to know how many coulombs it is.
Okay. So electrons is gonna go in the bottom. I'm gonna try to find coulombs on the top. Okay. Should I make a fraction out of this, or can I just?
No, just put it in.
Yeah. Okay. So what's attached to electrons is this number right here, 6.25 times 10 to the 18th electrons. And then on top, what goes with Coulomb?
Yep, 1 coulomb.
Number 1. Okay, now scientific notation. So so I multiply across, okay? And I realize some people just don't know how to do it with this. And they divide on the bottom. So I say 1 divided by, do I have to put the bottom parentheses?
No.
I do not. 1.25 times 10 to the 18th.
You guys know how to put scientific notation in your calculator, right?
Yeah, I use the E button.
Got to use it.
Mm-hmm.
You can't
No.
use the multiplication button.
Don't type in times 10 to the something. Now, some of you guys have calculators that have that already set up for you, but just don't type in times 10 caret, okay, 1.6, I can't read and talk, times 10 to the negative 19th. These cancel. Coulombs.
Coulomb.
Ah, that is a number.
That is a very small number. So
That
an
is very
electron has a
small.
very small amount of charge in terms of coulombs.
Yeah, okay. So the charge on a proton or an electron is that number that we just got right there. So a proton would be, it would have a positive 1.6710 to the negative 19 charge,
Yeah.
coulombs. And an electron would be negative 1 point. And you can see negative, positive, okay?
Cool.
All right, so if I was holding 1 proton in my hand, that's how many coulombs it would have. What is the total charge on 2 electrons, 200 electrons, and that big old number of electrons? Oh my God, there's a number.
Well, if one electron is 1.6 times 10 to the negative 19, 2
Right.
electrons would be
2 electron would just be, 2 divided by that.
3.2.
Is it 3.2?
Yeah, 2 times 16 is 32, isn't it?
Oh yeah, you're right. Okay. So basically you just multiply this by 2, and you get 3.2.
3.2 times 10 to the negative 19 coulombs.
Okay, and if you guys are like, Miss Moore, I don't trust Mr. Boykin's math, well, you should. But,
Well, no. You always want to do it yourself.
You can just plug it in, right? 2 divided by this, it'll get you that number.
What about 200 electrons?
Okay, so now this becomes 200. Okay.
So go ahead and put that one in your
Put that one in the
calculator.
calculator.
And I'm gonna predict that it's gonna be 3.2 times 10 to the negative 17.
I think you.
Because I got
might
2
be right.
zeros.
So 200 divided by 6.25 times 10 to the 18th. And we get 3.2 times 10 to the negative 17th.
Woohoo!
He does it again. So boop, boop, boop. So now it's to the 17th. Okay, and then.
Wait a minute, 6.02 times 10 to the 23. That's a familiar number to me. What is it? Isn't that avocado's number?
That is Avogadro's magical number.
So if you have a mole of electrons, and I cannot do this one in my head.
No, we'll type this one in. Okay, so we'll do 6.02 times 10 to the 23rd divided by 6.25 times 10 to the 18th.
Yeah.
Okay, and I get 96,320.
Coulombs. Holy smokes. That's a lot of charge.
Okay, oh, there we go. Okay, 96,000, what did I say, 320?
Let's call it, yeah.
Okay,
320
almost
coulombs.
10,000 coulombs, right?
Yeah, so if you have a mole of water, there's a tremendous amount of charge in there, but how come that's not dangerous? If you've got that many, and that should be negative, by the way.
Oh,
since
sorry,
doing
because we're talking about
electrons.
electrons, right? And you know what? All these should be negative, right?
Yeah. Yeah. So how come water with all that negative charge isn't dangerous?
Why isn't it?
Because for every negative,
We have a
positive.
Sweet.
It cancels each other out and it makes it neutral.
There we go.
Sweet.
Okay, so is this making sense? I hope so. Okay. How many electrons are required to add up to -4 times 10, -4.0 times 10 to the -16th coulombs? Okay.
So now we're starting with coulombs and we want electrons in the answer.
Just erase the board but keep the structure because it's the same every time. Okay. All right, so here we go. We've got how many electrons? So we're trying to figure out electrons now, right?
Yeah.
Okay. Okay, required to add up to -4.0 times 10 to the
-16 coulombs.
coulombs. Okay, so whatever I want is here then here, right? They gotta cancel.
So we make a fraction out of that.
What's attached to electrons? Electrons, bada boom. Okay, and then, okay, here we go.
The coulombs cancel, and what you get is,
Yeah, we multiply and cross, divide by, 1,
Yeah.
so don't do anything there. -4 times 10 to the -16th?
Yep.
Okay, times 6.25 times 10 to the 18th. And I get -2,500. Okay, -2,500. Oh,
okay, now I think that the charge on one electron is negative.
This
That
right
should
here,
be
right?
-1 coulomb.
Yeah.
No.
oh.
The coulombs is negative at the bottom.
Coulomb is negative.
So you got a negative divided by a negative, which gives you a positive.
Mm-hmm.
Because if you have electrons, you can't have a negative number of electrons. It's
Yeah.
like you can't have a negative number of people.
Yeah.
You can have a number of negative people, but you can't have a negative number of people.
Yeah, so it says how many electrons. You can't have -2,500 electrons. You have to have just 2,500 negatively charged electrons.
As you get smaller and smaller, fewer and fewer electrons, you got 2, 3, 2, 1, 0. You got no electrons.
Yeah.
Ain't no such thing as -1 electron.
Yeah, so you gotta make it work. All right, and this number right here, Boykin, is this number supposed to be negative?
Nope,
though?
that's
No?
a number of protons. That's a
the
number
number.
of electrons.
That's the number of, oh yeah, you're right. The number of protons is that, the number of
And the
electrons.
charge is negative. The
Okay, the
coulombs
charge
is
here.
negative or positive.
Yes. Okay, that makes sense. All right, moving on here. Attraction and repulsion are electrical forces.
Yep, they're forces.
We learned this. Okay. Electrical forces act between at least two charged objects.
Yep.
Okay, so we have to have these two objects to have electrical forces. They've got to be charged. Okay, what determines how strong the electrical force of attraction or repulsion is?
It's a good question.
Think about it.
Based on what we've been playing with so far.
Yeah, the electroscope, all that jazz.
Yeah.
Okay. What are you trying to do when you keep rubbing the balloon on your shirt? So you guys didn't get to do this, like.
Unfortunately, however, the more you rub the balloon on your shirt, what is it you're trying to do? You're trying
so
to.
You guys are like, so in our experience, when you guys do this lab in person, people will be like,
Many, many times. I like that.
right, doing their very best to try and
Get more electrons on your shirt.
to get more electrons on our shirt. Okay, so the goal here is to try to get as many electrons on our shirt.
Yeah.
What does the electroscope do when you get the rod closer and further away? Okay, so I'm charging by conduction here. Oh no, induction, right?
No, you're just rubbing.
Oh, I am.
Yeah.
Am I gonna?
Okay, nothing, something, something. Nothing, something. Nothing. So the closer, the stronger, the farther, the weaker, right?
Mm-hmm. Okay. All right. So here we go. This is the answer to our question. Electrical forces, represented by, we've seen the force of gravity, the force of tension, the normal force. The electrical force here depends on the quantity of the charge, Q, which was when we were rubbing the balloon, Pekka, okay, acting and how far apart they are. So how far, close,
Yep.
we bring it to the thing, okay?
So here's the relationship.
The relationship is here, okay? So more charge means more force. The more you rub the balloon on there, okay, the more electrical force you are going to have.
Yeah, so here's the charge on one thing times the charge on the other equals a force. If you got more charge, you get more force. This means proportion.
Yeah, and you gotta have two things.
Two things to
Okay.
tango.
All right, and then here is the other idea. So the electrical force, less distance means more force.
Yeah.
Right. The closer we are, the greater the force.
Yeah.
Right. And so, did we want to talk
That's
about
that's an inverse relationship. So
Yeah.
as the number on the bottom of the fraction gets larger, the whole fraction gets smaller,
Yeah.
and vice versa.
And what do you call this? The inverse square
Inverse,
law.
yeah.
Right. That's like a thing. So yeah. Okay. That's all there is. Now
So
these are pretty much. Well, I guess we can.
If you
combine
put them together, you get this.
Yeah, and this is really pretty. It's a, but it's kind of useless as of right now because we don't have any sort. We need a constant.
So this is, yeah, go ahead.
This is helpful, but
It's called Coulomb's law.
This is what we need. Oh, Coulomb's law, yes. So this proportion is changed to an equation using our constant K, which is 9.0 times 10 to the 9th Newton meter squared Coulomb squared.
That's a big number.
It is. It's a very big number. And so what does that look like? Here it is.
Here's Coulomb's law. Write this down in your notebooks, boys and girls.
You need this.
The electrical force is K times Q1 times Q2 divided by the square of the distance between them.
And what was that number? K equals 9.0 times 10 to the 10 to the.
Negative, no, 10 to the positive 9 times 10 to the 9 Newton meter squared over Coulomb squared.
Bada boom. Okay. And you need this equation as well. Okay, let's rock and roll. What is the electrical charge between these charges?
Electrical force between these two charges. So we got -1 coulombs, +2 coulombs. They're 1.5 meters apart.
Okay. Should I do it right here, you think?
Whatever you like.
Let's do it. I don't have anything underneath there today. Okay, so we know that in order to find the electrical force, it needs to be K times Q1 times Q2 over R squared, D squared, sorry.
Yeah.
Okay. And so let's go ahead and just plug this in, right? So we've got 9 times 10 to the 9th newtons meters squared over Coulomb squared. Okay, times, this is my first charge.
-1.
1 and 2. -1 Coulomb times 2 coulombs. And I put this all over 1.5 meters squared.
Yep.
Don't forget to square it. Okay, let's do it. Now, do I need parentheses?
Nope.
Nope, just plug it all in. 9 times 10 to the 9th times -1 times 2 divided by 1.5, but don't forget to square it. And I get wowzer. Okay, let's see.
I can't see it.
It's like 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that 9? I think so, yeah, because there's. Okay, we're going to call it. Okay, so 8.0 times 10 to the 9th. And what are we talking about here?
Newtons.
Newtons.
See, because you got meters squared cancels meters squared, and coulombs times coulombs cancels coulombs squared. And you're
Boom.
left with newtons.
Newtons, okay?
Okay,
oh, right
so
here. I was like, where are my newtons at? Okay, bada boom. Okay, so that's for that first one right there.
it's just a matter of plugging it into the equation.
Yeah.
What's the next one?
Same thing, but different numbers. Okay.
So now we're 2.5 meters apart,
Okay.
and we got less charge.
So I'm gonna go. Should I erase this or should I do it
I would
again?
only erase this and the
Yeah.
bottom.
Okay.
Everything else stays the same.
Okay, so. All right, so here's my first charge, which is -0.5 now, and here's my second charge, which is -0.2, and then another 2.5 apart.
2.5 meters.
And don't forget to square them more. Okay. So here we go. 9 times 10 to the 9th times -0.5 times a -0.2. Oops, wrong. 0.2 I divide by 2.5 squared.
Yep.
And I get another really big number. This time it is 1.44 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8.
So it's less force than the other one,
Less
but it's still a
force.
huge amount of force.
Okay, so one thing, I want to point something out before I go to the next slide. So for the first one, okay, well for the second one, we have a negative charge here and a negative charge here, right?
Yep.
And the first one, the last one was a negative and a positive.
Yep.
Okay, let's use these for on our next slide here. Okay, what does it mean if the electrical force is positive or negative?
Well, the thing that determines a positive or negative is the charge on the charges, positive or negative charge.
Yeah, okay, so when we multiplied our charges together here, a negative plus a positive, that's overall going to be a positive charge, right?
Negative times a positive is positive.
Okay.
Well, no, negative times a positive is negative.
Oh, sorry. See, this is what I'm talking about. You guys are like, no, it's more, okay. It's a negative. And then if I do a negative times a negative, that gives me
Positive.
a positive.
So
all right?
what does it mean if you have opposite charges?
So if we have opposite charges, okay, opposite charges,
Attract.
that means we have attraction, right? So that means when we have a negative answer,
That's attraction.
that's attraction. Now when we have opposites,
No, those are the same.
I'm sorry, when we have the same, excuse me, they repel. Did I spell repel right?
Yep.
Okay. They repel. And so when we have like charges that, when we have the same charge, they repel. Excuse
Yep.
me. Okay. So that means when our answer is positive,
That's repulsion.
it's repulsion. Wrap your head around that.
Yep.
Makes sense, right?
Are we about done? I hope
Yeah.
so. This has been a long one.
Oh, shoot, wrong way. Okay. All right, so here we go. Two charges are separated by 0.03 meters. Object
I think what we
A-
should do, Miss Moore, is make this homework.
Yeah, let's make it homework, okay? So go ahead and take a stab at this. So you've
There's
got
the
this
distance.
question.
There's the charge on one. There's a charge on the other. Use Coulomb's law. Figure it out.
Wait, we've got one more.
No, we don't have to. Oh,
No.
you want them to do two?
Well, you know what? I could do this one. Ooh, I could do this one for the warm-up tomorrow.
I like that.
Yeah, okay, just do this one.